So we do understand that this is a very simple, straightforward question based on this equation of simple harmonic motion. Now the question here is, how is the maximum velocity V max is equal to A times omega? How? But to solve this question, we don't need this how. Because we've been given in the question that the amplitude is 0.06 meters and the time period is 3.14 meter. We know that the maximum velocity in a simple harmonic motion is A omega. Omega is 2 pi by t. T is 3.14. So pi by 3.14 is 1. So this is 2 into 0.06, which is 0.12 meter per second. The tricky part here is the answer is to be found out in centimeter per second. Therefore, 0.2 meter per second has to be converted to, my bad, meter per second has to be converted to centimeter per second. And therefore, 0.012 becomes 0.12 times 100, which is 12 centimeter per second. Okay. So yes, that's the question. I would like to take you. See, I do understand that this is 1, 2, and the third question in this chapter, right? So we haven't dealt with many of the concepts, and if you're following the series for the so far, you might be able to recall some of the things that we have learned in work energy power as an extension of those topics in exactly, which is motion of a spring. Now, what we'll do is we will try to understand the mathematical parts of this simple harmonic motion in a set of the first initial problems. Slowly, we'll try to visualize what these motions represent. And then we will move on to, okay, let me just write it down as well. So first, we will use it only based on equations. Then we'll solve it using the visual methods. Like we'll try to understand what this simple harmonic motion represents in a visual way. We'll take some examples, and then we'll use the phasor diagram to solve this. Okay. Now, some of us might find phasor diagram easy to solve this. Some of them might find it equations. That's totally up to individuals. But I would suggest that you learn how to solve any question in both these ways. Okay. So let's just have a quick recap of what is simple harmonic motion. It's a simple harmonic motion in simple terms. Is a motion where the particle moves back and forth around a central point, which is otherwise called as the mean position. It will have maximum speed at the center. It will have zero speed at the two extreme ends. And it will keep repeating the motion in a fixed time, which is called as the time period. Okay. In this question, the problem that's given to us, time period is the total time is 3.14, which actually means the total time to go from one side to the other and then back to the original position. Now, what is amplitude? Amplitude is how far the particle moves from the center in one direction. For instance, how high the swing goes from the middle. Okay. Now, maximum velocity happens when the particle reaches the center. You can feel free to skip writing these things. Okay, that's not. Well, you can, but I wouldn't suggest that. When is the velocity maximum? The particle slows down at the ends, turning point, which actually means it reverses the velocity direction. It speeds up as it approaches the center, which means it is accelerating. It is fastest at the center. Which position? The mean position. So when they ask for maximum velocity, they are indirectly asking you the particle speed at the center of its motion. So both of them can be interchangeably asked. Okay. Now, what are the various quantities in simple harmonic motion? If we were to compare this with a linear motion, see, we discuss displacement, velocity, acceleration, time, horizontal displacement, vertical displacement, theta, the angle of projection, all these when it comes to motion in general, right? Very similarly, when it comes to describing motion in simple harmonic motion, we make use of certain quantities which are displacement, velocity, maximum velocity, acceleration, and maximum acceleration. Displacement is given by x of t is equal to a sine omega t plus phi, or as x of t is equal to a sine omega t. Velocity as a omega cos omega t plus phi, or as a omega cos omega t. Likewise with maximum velocity, acceleration, and maximum acceleration. Now you might be wondering, there are many more. There are two ways to represent the simple harmonic motion, and there are multiple parameters associated with it. Then how do we know? How do we get, how do we get to select one? That's very important. To understand that, we will first have to know how do we actually arrive at these equations. So we know that the ordinary differential equation representing a simple harmonic motion can be given by d square x by dt square plus omega square x equal to 0. How did we arrive at this? Yes, we already have derived this, right? F of x is equal to minus kx, f of x is equal to ma, and then we arrive this equation. I'm not going into the part of derivation here. Now, the solution to this ordinary differential equation is of the form x of t is equal to a sine omega t plus phi, or x of t is equal to a cos omega t plus phi. Yes, this is one point where most of us might find it difficult to choose sine omega t or cos omega t plus phi. Now, for the time being, let us focus only on a sine omega t plus phi, okay, and the variations, the special cases that arise out of this. All the calculations, all the numericals that you solve with a sine omega t plus phi can also be solved with a cos omega t plus phi. No doubt about it. But there are certain things that we need to understand, which if I start to explain all those in one single question, it is going to be a bit overwhelming for you. Okay, so let's not try to, decipher the complete chapter in one question. No. So some of the questions, in fact, most of the questions we'll solve it using x of t is equal to a sine omega t plus phi. As we do more number of questions, your concepts will start building up. Trust me. Okay, please be with me. Please make a note of these. Now, what are the special cases? Now, when I mean special cases, the general equation is x of t is equal to a sine omega t plus phi. But if the motion is starting at x equal to a, we use x of t is equal to a cos omega t specifically. If the motion is starting at x equal to 0, we use x of t is equal to a sine omega t. What's the criteria? Depending on the initial condition at time t is equal to 0, we adjust the phase constant phi to match the scenario. I haven't discussed so far the relevance of phi. Yes, I do understand. That's exactly what I would like to emphasize here, that all these parameters, all these equations will not make sense in one single question. We have answered the question. We have found that we have solved the problem. We got the correct answer. Now we just try to extrapolate our knowledge a bit. Sequentially, we'll, as we go through a number of questions, your concepts will start building one by one. And then all of a sudden, all these concepts will start making sense together. Okay? Now, reference for numericals. If the motion starts from mean position, x is equal to 0 at t is equal to 0, therefore x of t is a sine omega t. Why? Because if you substitute t is equal to 0, sine omega t is become sine 0 is 0, therefore x of t is equal to 0. Matches it. If the motion starts from an extreme point, could be either of the extremes, plus a or minus a at t is equal to 0, x of t will be a cos omega t. Why? Because cos 0 is 1. So if we substitute t equal to 0 here, let me just write it down here as well. We substitute cos t equal to 0. This becomes cos of 0. What is cos of 0? Equal to 1. And therefore, what is x at time t is equal to 0? It is equal to 1. If motion starts from any random position, not the mean position or the extreme position, we use the equation x of t is equal to a sine omega t plus phi. What is phi? In simple terms, phi accounts for the phase shift where the particle is at t is equal to 0. More of this in the next question, the next immediate question. Okay. Now, we need to spend a couple of more minutes to understand some things here, because we were thinking of this question: how is V max is equal to a omega? Let's try to understand that as well. So just now we discussed that x is equal to a sine omega t and can be represented in a different way as x is equal to a sine omega t plus phi. What is varying? The phase at which the time of observation has started. Sorry, at the time at which the observation has started. Okay. If you differentiate x, again, whenever I say x, I mean x of t. What we get is velocity of t as a function of t. Is a derivative of sine omega t is cos omega t, derivative of omega t is omega, so we do a omega cos omega t. Similarly, derivative of a sine omega t plus phi is cos omega t plus phi into derivative of omega t, which is omega. So we get a omega cos omega t plus phi. Velocity is a omega cos omega t, or velocity is a omega cos omega t plus phi. Now, most of the time, I see some of us making this mistake here. They assume like this: phi is equal to 0 and t is equal to 0. Therefore, at t is equal to 0, x is a sine. What is x? X is equal to a sine omega t plus phi. And therefore, you get x is equal to a into sine 0 plus 0, which is x equal to 0. By the same logic, what is velocity? Velocity is a into omega cos omega t plus phi. So you substitute t is equal to 0 here and phi is equal to 0, which gives us cos 0 plus 0, which is 1, and therefore velocity at t is equal to 0 as a omega. And then you say that velocity at t is equal to 0 is the corresponding Vmax. No, this is not the case. Yes, velocity at the mean position is equal to the maximum velocity, no doubt about it, but need not be the initial velocity t is equal to 0 as the maximum velocity. Hope that makes sense. It's a very important observation. Please make a note of this. So now you might be wondering, if this is not how velocity at a point becomes maximum, then how did we get this expression? To understand that, we'll have to revisit this equation. Vmax, okay, we need to find out Vmax in both cases. V is a omega cos omega t. V is a omega cos omega t plus phi. Acceleration here, acceleration is a constant. Omega is a constant. So acceleration is a constant, omega is a constant, which means velocity depends only on cos omega t. Or in other words, velocity is proportional to cos omega t. Very similarly, acceleration is constant, omega is constant, which means velocity is proportional to cos omega t plus phi. If velocity is proportional to cos omega t plus phi, it means velocity is minimum when cos omega t is minimum, and velocity is maximum when cos omega t is maximum. When is cos omega t maximum? Is a question. But what is the value of maximum value of cos omega t? Is 1. So V is equal to V max implies, irrespective of whichever position it is, cos omega t should be equal to 1. There can be many time intervals where cos omega t is 1. Irrespective of which time interval it is, the maximum value has to be 1. And if cos omega t is 1, what is V equal to? V max, which means V max will be A into omega into cos omega t replaced by 1. Very similarly, V is V max when cos omega t plus phi is maximum. What is the maximum value of cos omega t plus phi? It is 1. So V becomes V max when cos omega t plus phi is equal to 1. That is how we get V max is equal to A omega. Hope that makes sense. Please feel free to reach out if you want me to explain this maybe in a different way, or if you want me to break it down further. Okay. So these little concepts make a lot of difference. Now, I'm pretty sure that most of you would have drawn the diagram that we have borrowed. You have borrowed the diagram that we've drawn while discussing the motion of a spring attached to a wall, right? So that will definitely help you in understanding the concept, but that diagram will not help you to visualize a simple harmonic motion beyond the limit. So I would recommend that you use the simple pendulum, the mean position, the maximum position, positive A, and the negative extreme, negative A. And as we do the next set of questions, we will make use of this diagram and the graph to understand our concepts better. Okay. Right. Now let's move to the next question.